along a path. Okay, we are still in the 11th standard. If limit as x tends to a plus f of x is not equal to limit as x tends to a minus f of x, then we say that limit of f of x is not exist at x is equal to a. It means that if left hand limit is not equal to right hand limit, then we say that limit of f of x is not exist at x is equal to a. Similarly, in the function of two variable, we have if f of xy tends to L1 as xy tends to AB by path C1 along a path C1 and f of xy tends to L2 as xy tends to AB along a path C2. That is, by path C1 we have a limit L1 and by path C2 we have a limit L2, and where L1 is not equal to L2, then we say that limit at xy tends to AB f of xy is not exist. म्हणजेच काय बघा, लिमिट एक्झिस्ट होण्यासाठी कुठल्याही पाथने गेला तरी लिमिट युनिक पाहिजे. जर युनिक लिमिट मिळालं तर लिमिट एक्झिस्ट होतं. जर एक, दोन किंवा दोन पेक्षा जास्त म्हणजे L1 आणि L2 ह्या पद्धतीने जर लिमिट मिळाले तर लिमिट does not exist, because if limit exists then it is unique. Okay, now we see the example. Example 1. Limit as xy tends to 0 0 x square minus y square upon x square plus. We have to find the limit as xy tends to 0 0 x square minus y square upon x square plus y square. Okay. Solution. In this solution, we firstly find limit along x-axis. You know that if we are going to limit along x-axis, that is the equation of x-axis is that y is equal to 0. The equation of x-axis is that y is equal to 0. That is y is equal to 0. Then we have limit as xy tends to 0 0 x square minus y square upon x square plus y square is equal to limit at x square plus y square upon x square minus y square is equal to, but here y is equal to 0, so we get limit as xy tends to 0 0 xy tends to 0 0 x square upon x square is equal to that is limit as xy tends to 0 0 1 is equal to, because limit of constant is constant. Next one is allow limit allow y. For finding limit along y-axis, we have an equation that is x is equal to 0. X is equal to 0. Therefore, we have limit as xy tends to 0, 0. Limit as xy tends to 0, 0. X square minus y square upon x square plus y square is equal to, here we know that x is equal to 0, therefore we are putting value of x is 0. Then we get x square means 0 minus y square upon y square is equal to minus 1. Okay, now limit along x axis is 1 and limit along y axis is minus 1. Therefore limit as xy tends to 0, 0 along x axis is 1. F of xy is 1 by x axis or along x axis, and which is minus 1, that is both limits are not equal. Therefore limit as xy tends to 0, 0. F of xy means x square minus y square upon x square plus y square is not x. Because if limit is exists, then it is unique. Here we are finding by x axis. If limit along x axis is 1 and limit along y axis is minus 1, therefore both are different limits. Therefore this limit is not exist. Now, second. Okay, now second example is a show that limit as xy tends to 0, 0. Solution: let f of xy is equal to xy upon x square plus y square. And if you are to show that, let limit as xy tends to 0, 0, xy upon x square plus y square is not exist. Not x. You have to show that let not exist. That is, you have to show that this has more than one limit points. That is more than one limit. So let we have an path y is equal to mx. Y is equal to mx. That is limit as xy tends to 0, 0 along y is equal to mx path. Now y is equal to mx path, we have limit as xy tends to 0, 0, xy upon x square plus y square is equal to limit as x tends to 0. Limit as x tends to 0. We have x into mx is m into x square upon x square plus m into m square into x square. Therefore, we have limit as x tends to 0. X square get common, x square m upon x square in a bracket 1 plus m square. That is, we have x square get cancelled. Limit as x tends to 0, m upon 1 plus m square. Here m upon 1 plus m square does not depend on x, so we have an answer m upon 1 plus m square. Okay, that is the value of limit, it depends on m. Therefore, the value of limit value of limit depends on m. That is, the m will be changed, then the limit value is also changed. जर m change केला तर आपली limit value काय होणार आहे? Change होणार आहे. Therefore, it has no unique limit value. That is, therefore, limit as xy tends to 0, 0. F of xy means xy upon x square plus 1 square is not exists. Because the limit value is depend upon the m. If m changes, then the limit value are also changed. That is, limit of this function is not changed. It depends on the path. Okay. Now, next example. Now, same example. Limit as xy tends to 1, 0. Xy tends to 1, 0. Xy minus y upon x minus 1 square plus y square. Okay, we have to show this function. So we can take f of xy is equal to x in a bracket, you getting y upon y in a bracket x minus 1 upon x minus 1 bracket square plus y square. We find limit along the path y is equal to m x minus 1. Sorry, x minus 1 is equal to m along the path x minus 1 is equal to. ह्या बात आपने क्या करना है? लिमिट चेक करना है. Therefore, as x tends to 0, we have x tends to 1, y tends to 0. Therefore, limit as xy tends to 1, 0, y x minus 1 is my, y into my divided by, we have y in the bracket x minus 1 upon x minus 1 bracket square plus y square. If you put the value of x minus 1 is my, so we have limit as y tends to 0, y into my divided by m square y square plus y square. Here is a limit as y tends to 0, m into y square upon, if we get y square common on both the terms, we get m square plus 1. Y square get cancelled, and limit as y tends to 0, m upon m square plus 1 is constant, so we have m upon m square plus 1. Here also the limit of the value is depend on m. Here limit value depends on m. लिमिट वैल्यू m वरती डिपेंड आहे आणि m चेंज केला तर लिमिट काय होणार आहे? चेंज होणार आहे. therefore limit xy tends to 1, 0, x minus 1 into y upon x minus 1 into y upon x minus 1 bracket square plus y square is not exist. Because the value of limit value of this function is depend only on m, that is path. If we change the path of the y is equal to path of the example, then we have another limit. Okay. Now, next point is a limit using Euler formula. For limit using polar coordinate, we have if r theta are polar coordinates of the order pair xy, that is x is equal to r cos theta, y is equal to r sin theta, x is equal to r cos theta, y is equal to r sin theta, then r greater than equal to 0, we have, because r is the radius of circle, that is r is greater than equal to 0, we have r tends to 0 plus as xy tends to 0. म्हणजे ज्याला xy 0 0 जातील त्याला r कुठे टेंड्स होणार आहे 0 प्लस thus limit as xy tends to 0 0 f of xy is equal to limit as r tends to 0 plus r tends to 0 plus f of r theta. F of r theta. That is r cos theta and r sin theta. Because x is a r cos theta and y is a it is also the function of f. Okay, म्हणजे याच्यामध्ये काय सांगितलंय r theta हा पोलर कोऑर्डिनेट आहे xy चा and we know that x is equal to r cos theta and y is equal to r sin theta, then r is always positive, then we have r tends to 0 plus if as r tends to 0 plus as xy tends to 0 0, thus limit as xy tends to 0 0 f of xy is equal to limit as r tends to 0 plus f of r cos theta comma r sin theta, because x is r cos theta and y is r sin theta. Now you see the example using polar coordinate. Using polar coordinate, find the limit, and the limit as xy tends to 0 0, limit as xy tends to 0 0, x cube plus y cube upon x square plus y square. For finding this, we know that x is equal to r cos theta and y is equal to r sin theta, and r tends to 0 plus as xy tends to 0. So we have limit as xy tends to 0 0, xy tends to 0 0, f of xy is equal to limit as xy tends to 0 0, x cube plus y cube upon x square plus y square is equal to limit as, we know that as xy tends to 0 0, we have r tends to 0 plus, here is a r cos theta cube, that is r cube cos cube theta plus r cube sin cube theta divided by r square cos square theta plus r square sin square theta. Okay, now we will take a common from these two terms, r cube. So we have limit as r tends to 0 plus r cube in a bracket cos cube theta plus sin cube theta divided by r square in a common cos square theta plus sin square theta. We know that cos square theta plus sin square theta is 1 and r square and this r cube is cancelled, we have only r. If we put r is equal to 0, then we have value is 0. Therefore limit as xy tends to 0 0 x cube plus y cube upon x square plus y square is a 0. I repeat this question, that is using for polar coordinate find the limit as xy tends to 0 0 x cube plus y cube upon x square plus y square. For finding this we have polar coordinates x is equal to r cos theta and y is equal to r sin theta, and r tends to 0 plus as xy tends to 0 0. Okay, now limit as xy tends to 0 0 f of xy is equal to putting the value of f of xy and put x is equal to r cos theta and y is equal to r sin theta. We have in this equation, if you common r cube from these two terms and r square from these two terms, we have r cube in a bracket cos cube theta plus sin cube theta and r square in a bracket cos square theta plus sin square theta. Here cos square theta plus sin square theta is 1 and r square goes to cancel. We have only a numerator r. So if we take r tends to 0, then r goes to 0. Therefore we have an answer